Another simple kind of t-test that we'll often run is to test whether or not there is statistical evidence to believe that the means of two populations from which we're sampling on a certain parameter are different. And the way to do that is the independent samples t-test. And the independent samples t-test has some assumptions we go over in class, but it's basically comparing two independent groups and comparing them on their levels of a particular variable. So to do that test, we go to Analyze, Compare Means, Independent Samples t-test, and we have a test variable. Here, this is the spiritual well-being data, so let's put spiritual well-being as what we're testing to see if there's a group difference. And then a grouping variable. The grouping variable is the factor that distinguishes between our groups. And so I want to look and see if gender is a source of difference on spiritual well-being. You put it in there and it asks you for what two values of that variable we are looking at. And so you have to hit define groups to do that. Group 1 is 1, group 2 is 2. And you could also set a cut point so that it would divide up a continuous variable at a certain place. But here we have two specific variable levels in that categorical variable. And we hit continue. Always click on options to see what's there. This again allows you to have 95 or 99% confidence intervals for doing this. Remember, confidence intervals are a widely embraced alternative to null hypothesis significance testing, but we'll talk about those in a couple of weeks. And then we have what we do with missing values. Do we just leave them out case by case, or do we say that a missing value means that that whole person's response pattern is likely to show some bias across everything, and so we exclude the cases listwise? Here we'll just do it case by case. Hit OK, and here we go. We have our output again, gender 1, gender 2. There are 25 of the men and 52 women. Mean for the men is 91.2, mean for the women is 95.8. Here's their standard deviations. Remember, one of the assumptions for the independent sample test is that there is homogeneity of the variances of the variable in question amongst the two groups. And so that is your assumption, that the variance in spiritual well-being for men is the same as for women, and SPSS gives you a test for it. This is Levine's test to see if that is true. It gives you F, which is a test statistic, just like T, and it gives you the significance. You are testing this to see if it is significant at the 0.05 level. This is not significant at the 0.05 level, so that means that we can assume equal variances. If this were significant, that would mean there's evidence that the variances are not equal. We have two lines. Equal variance is assumed. Equal variance is not assumed. This tells us which one of those to choose. Since it is not significant, we just go with our assumption of equal variances. Here's our t-value, degrees of freedom, significance, 0.243. It is not statistically significant, so we have no evidence from our sample that the two populations differ in their mean levels of spiritual well-being. And then here we have mean difference, standard error of the difference, and a confidence interval for the difference. This says 95% of the time the difference should be somewhere between minus 12.6 and 3.25. And since that includes 0, it could be that 0 is the real difference. And that's how we do the independent samples test.